Okay, so today we're going to be talking about dilutions. And dilutions are just as they sound. It's diluting a product. Diluting takes a higher concentration product and turns it into a lower concentration product. So for example, I have these liquid soda drops that I use in my soda stream. I can add a certain amount of drops. If I add too much, I can always add more water, mix it in there, and it will be, once again, at that lower concentration or lower taste for me. So that's how you can adjust. You can either keep adding more active ingredient to create a higher concentration of product or a stronger taste, or then you can add more water to create a lower concentration of product or active ingredient, and that would be less of a taste. This is how we do it with medication concentrations. And sometimes we need to know exactly how much of a certain percent concentration we need to then mix with a diluent to get the amount of concentration that we're looking for. So here you can see in this picture we have the same amount of active ingredient, but as we add more diluent or we dilute it more, then we can see we end up with a lower overall concentration of active ingredient in our mixture. So if we ever need to take a higher concentration and create a lower concentration, we can do that via diluting it. So dilutions are when you manipulate 1% based product to create a second percent based product. So I'm highlighting that you're using one product to create a second because the next set of problems that we're going to go over are called allegations. And allegations mix two different percent-based products to create a third percent-based product. So I don't want you guys to get confused between these two types of problems. So in order to start going over dilutions, let's learn the formula. So the formula for dilutions is starting concentration times starting volume equal to final concentration times your final volume. I'll write that below for you, just so you can reference later. Okay, so feel free to pause your screen, go back to this whenever you need to. So one important thing to note, so I'm going to write it in red, is that because we're working with percents, we need to have everything that we're working with in either grams or milliliters. So if you're given a volume with anything that's not milliliters, you need to convert to milliliters before plugging into this equation. So anything in this equation needs to be in grams or milliliters. For your concentration, you plug the percent directly in because concentration is the ratio of your active ingredient over 100. So writing in percent directly would just be taking the concentration of that active ingredient or your parts of a whole. So let's just say the concentration is 5. Remember, we can write 5% as 5 over 100. And we know that our concentration is looking at these parts of a whole. So that 5. So that's why we can write our concentration simply by adding in that percent. We don't need to make it, a decimal like we normally would make our percents. 5% could be written as 0.05. We don't have to do that. We're simply writing in our parts of a whole, or 5. Alright, so in our first example, we're going to be finding volume. So for this example, we're going to be looking at how many milliliters of a 2% solution will we need to then dilute to create 250 milliliters of a 0.5% solution. So as you can see here, we're starting with our higher concentration, we're diluting it by adding a diluent, and we're ending up with a lower concentration. Due to the fact that we know we're going to have to add a diluent, we're going to start with a smaller amount of milliliters and then end with a larger amount of milliliters to then get our smaller concentration of overall active ingredient within the product. So that's what we're expecting. So first off, what I want you guys to see is we have 250 milliliters of a 0.5% solution. Anytime you see of a whatsoever, we know that these values are going to go together. In this case, it's going to be our final concentration and final volume. But we know that these units will be together because it's 250 milliliters of this percent. So if you are struggling to know which volume goes with which concentration, then that's how. Look for these keywords of a within your problem. Let's set this up. So in order to set these equations up, I always just find my values first before I plug anything in. So this is how I set up my paper. Starting concentration, starting volume, final concentration, final volume. So as I said, we know that this part right here is our final because that is what we are trying to find. We can plug that in right here. Volume is 250 milliliters. We don't have to convert because it's already in milliliters. I told you guys before, if it's not in milliliters, you have to make it in milliliters before you plug it into this problem. So 250 milliliters for our volume. Our concentration, as I said, we can plug it directly in, so 0.5. And we want to know how many milliliters of a 2%. 2% would be our starting concentration, so we can just write 2. And then for starting volume, that would be our X, because that is what we need to find, because it's asking how many milliliters. Milliliters are volume units. So even if you somehow get confused between what is supposed to be your starting and what's supposed to be your final, as long as you know when you see of a, those go together, then you're going to be able to plug it in for the same. You just need to make sure that your units go together. So you need to make sure your starting concentration and starting volume are on the same side of your equation, and your final concentration and final volume are on the same side of your equation. So let's plug this in. 2x equals 0.5 times 250. We get 2x equals 125. Divide both sides by 2 to isolate x. And we get 62.5 milliliters. So we would have 62.5 milliliters of a 2% solution in order to make 250 milliliters of a 0.5% solution. Okay, so now we have an example where we're finding the concentration. So if 250 milliliters of a 20% solution is diluted to 1 liter, what will be the percent strength of the final product? So once again, I'm going to set up for my equation. So starting concentration, starting volume, final concentration, final volume. Now, it already says what will be the percent strength of the final product. So we already know that our X is going to be our final concentration. We're diluting the product to 1 liter. So But we remember, we can't have our final volume in liters. We'll convert that later. In the original, remember, I told you guys that when you see of A, it goes together. So our original volume, before we do anything, would be our starting volume. And that is 250 milliliters. And that goes hand in hand with our 20 of 20%. So now let's convert that 1 liter into milliliters. So for that, I'm going to write down my acronym. Keen Henry died by drinking chocolate milk. And we're going from our base unit of liters to milliliters. So 1, 2, 3. I made 3 loops of my decimal point to the right. 1, 2, 3. Fill in zeros for our loops, and we get 1,000. So we can put 1,000 milliliters. Cross that off so we don't get confused. So now let's fill it in for our equations. So remember, our equation was starting concentration times starting volume equals our final concentration times our final volume. So starting concentration, 20 times 250 equals X times 1,000. And if we multiply 20 and 250, we get 5,000. Divide both sides by 1,000 to isolate X, and we get X equals 5. So our final concentration would be 5. The percent strength of the product would be 5%.